Now we've seen how we can take our 3D graph here and implement it into an actual engineering example. And the example we worked through was an NMOS enhancement transistor. So we're going off on a bit of a tangent here, so let's get back on course. We'll finish off in this video and we'll just talk through the rest of this enhancement device, and then we'll move back on to the actual 3D simulator. So we have our device here, and we mentioned that the device is going to have the current from the drain to the source along this axis, and we're going to have the voltage from the drain to source along this axis, and we usually see the transfer characteristics seen in this format, current against the voltage. But we've seen that we can get it in a 3D format, and we've got the 3D format here. So we're going to have the VDS here along this axis, we're going to have VGS, which is up here, and an IDS as well. Now you'll see this better just in a second whenever I move it round and you'll see the 3D. And we've also got attached here the actual device. So we're going to have a transistor, and we'll have an N-type, and also have a P-type region in here. And we're going to have the gate, and we're going to have a source and a drain, and it's going to have a certain width and a certain length. Now we can control the values for our gate, our source and our drain voltage here, and we can see that the outputs are going to be our V drain to source, which is given by this value, and also our VGS minus VT, which is this value here. So we can see here that at the moment we have the depletion region, which is this whole region here down to this blue line, and we can adjust the depletion region by adjusting the gate source voltage. So we can adjust this height here, and you can see as we adjust the gate source voltage, we're going to adjust this depth of this depletion region, and we're going to adjust the transfer characteristic. But all we're doing when we're doing that is going up along this 3D graph onto each of the individual transfer characteristics, and you'll be able to see that if I adjust the graph round at a certain angle. So if we head to that different angle, you see we're going to have our VGS here. So that's our gate to source voltage, and this is our gate to source voltage here. And it's going to be working our way along the back of this graph here, and we're going to be picking out individual transfer characteristics dependent on that value for VGS. And then we're going to actually work our way up along this characteristic, and we will be in the cutoff region down here when there's zero current flowing. And then we're going to be in the linear region here in pink, and eventually we'll move into the saturation region. And we can see that happening whenever we adjust the value for the drain voltage. And you can see the drain voltage here adjusting, and you can see the depth of the inversion layer changing, until we get to a point here which we get a pinch off. So the point here, we get a pinch off here when our VGS minus VT is equal to the VDS, and at this very point here we'll be at this corner of the curve, and after that we'll move into the saturation region, and the saturation region will be up along this section of the curve here. And you can see it again in the 3D graph. We're going to have our cutoff region here in blue, we're going to have our linear region in pink, and we're going to have our saturation region, which is this orange colour here. So that gives us a good indication of the working of the NMOS enhancement device, and it also shows how we can implement the 3D graph in order to give us a better understanding of this transistor. So that's us finished with this little section. Let's move on and we'll look at some other parts of our 3D simulator.